today's chemistry class. Today we discuss nucleophilic substitution reactions of haloarenes. Okay, so we have discussed the introduction of this in the last video. These haloarenes are least reactive towards nucleophilic substitution when you compare with haloalkenes due to the resonance effect as well as the hybridization of carbon atom. Now we come to the reaction. First one, reaction with NaOH. So we are taking the example chlorobenzene. So chlorobenzene on reaction with NaOH at a higher pressure followed by acidification, we get phenol. So chlorobenzene on reaction with NaOH we get and acidification you get phenol. So we can see the reaction here. First of all, this chlorobenzene reacts with NaOH, that is sodium hydroxide at 623 Kelvin and 300 atm pressure. You get sodium phenoxide ONA. So instead of chlorine you are getting sodium phenoxide. Then sodium phenoxide on acidification we get phenol. The product is phenol. This is the first nucleophilic substitution reaction. So here just a haloarene. So and in the case of substituted haloarenes, the reactivity is higher. Examples like when an electron withdrawing group such as nitro group is attached at ortho and para positions, the reactivity of this halo compound increases. This is due to the electron withdrawing effect of such a group. Due to the electron withdrawing effect in the benzene ring, the positive charge increases, so the nucleophile can attach the benzene ring very easily. So we can take the first example. Nitro group is attached at this benzene ring. Okay, here, and it reacts with NaOH. So the reaction is same with NaOH at 443 Kelvin, and then followed, this is the first reaction, followed by hydrolysis. We directly write this one. Okay, so you get same product, that is para-nitrophenol. This is the product obtained. Okay, para-nitrophenol is the product. So here instead of chlorine you get OH group. So OH group is obtained. So that is nucleophile. OH is OH minus. So you are getting a phenol. That is substituted. Instead of chlorine, OH group is substituted. That is nucleophilic substitution here. Okay. And we can move on to the next one. Next reaction. Okay. That means again we have ortho and para substituted group. That means this compound on reaction with NaOH. First of all, NaOH at 368 Kelvin. At 368 Kelvin, then followed by hydrolysis. You are getting the product. So same reaction. That means instead of Cl, you are getting OH. This is 2,4-dinitrophenol. This compound is 2,4-dinitrophenol. Okay, that means when this ortho and para substituted haloarene on reaction with NaOH followed by hydrolysis, you are getting 2,4-dinitrophenol. Okay, now we can take another example. If 2,4,6-trinitrochlorobenzene on reaction with warm water, on reaction with warm H2O, you are getting 2,4,6 6 trinitrophenol. 2,4,6 trinitrophenol. This is 2,4,6 trinitrophenol. This is a compound obtained. That means when 2,4,6 trinitrochlorobenzene reacts with warm water, you are getting 2,4,6 trinitrophenol. These are all about the nucleophilic substitution reaction. Okay. So here we have discussed the nucleophilic substitution reaction of haloarenes and as well as substituted haloarenes. You are getting the product and substitute when an electron withdrawing group is present in the halobenzene, the reaction is the reactivity is high due to the withdrawing effect of that group. Okay. Now we can discuss the electrophilic substitution reaction. Electrophilic substitution reaction of haloarenes. Electrophilic substitution. So we have already discussed the resonance structures of halogen. Once again we can go to the resonance structure of haloarenes. So this is our halo. Generally we can represent this is our halobenzene or haloarene. X means halogen. Okay. So this one electron is shifted from halogen and it forms a double bond. One electron is shifted from halogen and halogen gets a positive charge and there is a double bond is formed between carbon and halogen. And this bond is shifted to this carbon and you are getting a negative charge. Clear? In the second structure, this is shifted to this position and this bond is shifted to this carbon and you are getting the next structure. Negative charge here and X is positive always. Okay. And the next structure, this bond is, this electron pair is shifted to this position and this bond is shifted to this carbon and you are getting the next structure like this. Okay, it is minus charge here. Okay, so this is a resonance structure of haloarene. So this is ortho position, this is para position, this is also ortho position. Two ortho and one para. So these ortho and para positions are negative charges are there in this ortho and para position. So an electrophile can attack these ortho and para positions very easily. So electrophile can attack this ortho and para position very easily. But this halogen is also an electron withdrawing. Sometimes it can also attracts electron pair. So the reactivity decreases. So we can see that here haloarenes is our ortho and para directive group because ortho and towards electrophilic substitution haloarenes are ortho and para directing because we can say that at ortho and para position negative charges are there. So we can see the reactions. First one, nitration. The first reaction we are going to discuss is nitration. So when chlorobenzene on reaction with concentrated HNO3 and concentrated sulfuric acid, you are getting ortho nitrochlorobenzene and para nitro product. You are getting these two products, ortho and para nitro product. Okay, ortho nitrochlorobenzene. This is ortho nitrochlorobenzene and this is para nitrochlorobenzene. That means when chlorobenzene on reaction with the nitrating mixture, you are getting ortho nitro and para nitrochlorobenzene. Okay, now the next electrophilic substitution reaction, that is sulfonation. How these haloarenes react with sulfonation, or what is the product obtained when chlorobenzene reacts with concentrated sulfuric acid. What is the product obtained? We can see that when chlorobenzene reacts with concentrated sulfuric acid, you are getting orthochlorobenzene sulfonic acid. So at ortho position you are getting SO3H, and para position also you are getting an SO3H group there. Okay, at ortho and para position you are getting SO3H, and the product of the name of this compound is orthochlorobenzene sulfonic acid. Orthochlorobenzene sulfonic acid. This one para-chlorobenzene sulfonic acid. Okay, you are getting orthochlorobenzene sulfonic acid as well as para-chlorobenzene sulfonic acid. And this orthochlorobenzene sulfonic acid is minor product. Para-chloro, this is minor. Orthochloro part is minor, and this one is major product. Okay, ortho product is minor and para product is major. Okay, now this is sulfonation. Okay, this is sulfonation. Reaction with the concentrated sulfuric acid is known as sulfonation reaction. Now we can discuss the halogenation reaction. Halogenation. So in halogenation reaction, so we can discuss this one. When chlorobenzene on reaction with chlorine in presence of FeCl3. Chlorobenzene reacts with chlorine in presence of ferric chloride. In presence of ferric chloride, you are getting orthochloro and para-chloro products. Orthochloro and para-chloro products. Okay, so you have two products. That means this is orthodichlorobenzene, this is para-dichlorobenzene. Orthodichloro, this is para-dichlorobenzene. Okay, orthodichlorobenzene and para-dichlorobenzene, or it is known as 1,2-dichlorobenzene. In IUPAC system, this compound is known as 1,2-dichlorobenzene, and this one is known as 1,4-dichlorobenzene. Okay, so that is all about halogenation. Okay, halogenation reaction. So here we can see that all the substitution takes place at ortho and para position. The reason we have already discussed it, because the reaction takes place at ortho and para position, because the resonance structure, and at ortho and para position you have negative charge. Now we can discuss the Friedel-Crafts reaction. The next one is Friedel-Crafts reaction. Okay, Friedel-Crafts reaction. Friedel-Crafts reaction. First one we discuss Friedel-Crafts alkylation. Friedel-Crafts alkylation. So when chlorobenzene on reaction with CH3Cl in presence of anhydrous AlCl3, you are getting ortho and para substituted compound. So at ortho position you are getting a CH3, and as well as at para position you are also getting a CH3. That means orthochlorotoluene, this is para-chlorotoluene. Okay, so that means Friedel-Crafts, this is alkylation. This reaction is known as alkylation reaction. That means when a compound reacts with alkyl halide in presence of anhydrous aluminum chloride, you are getting an alkyl methyl group in benzene ring. This is known as Friedel-Crafts alkylation reaction. This compound is orthochlorotoluene and this compound is para-chlorotoluene. Now we can discuss Friedel-Crafts acylation reaction. Acylation reaction. So here, when chlorobenzene reacts with acyl chloride is CH3COCl in presence of anhydrous AlCl3. The same reaction takes place at ortho and para position. You are getting this COCH3. So chlorine will be there and COCH3, one product. Okay, then another chlorine will be there and COCH3 will be there. These are the two products obtained in this reaction. That means the name of the products are orthochloroacetophenone and parachloroacetophenone. So when acylation means a chlorobenzene reacts with acyl chloride, substitution of acyl group. Okay. So chlorobenzene reacts with acyl chloride in presence of anhydrous AlCl3. You are getting orthochloro. This compound is acetophenone. Orthochloroacetophenone, and this compound is parachloroacetophenone. Okay, that is all about the nucleophilic and electrophilic substitution reactions of haloarenes. Okay. So next reaction we discuss is reaction with metals. First one, fatigue reaction. Haloarenes reacts with metals. We get two different reactions. First one, fatigue reaction. This is known as fatigue name reaction and very important. Here, haloarenes on reaction with metallic sodium, metals like sodium, you get diphenyl, or it is also known as biphenyl. So fatigue reaction is the reaction when haloarenes on reaction with sodium in presence of either, you get biphenyl. So we can take the example chlorobenzene. Chlorobenzene, two molecules of chlorobenzene reacts with two molecules of sodium in presence of either, you are getting diphenyl or biphenyl. It is known as diphenyl or biphenyl plus 2NaCl plus 2NaCl. This is known as fatigue reaction. Chlorobenzene on reaction with sodium in presence of either, you are getting diphenyl. This is known as fatigue reaction. Two benzyl rings are attached, diphenyl or biphenyl. That is the name of this compound. Okay, now we can see the next reaction, that is Wood's fatigue reaction. Wood's fatigue reaction. Wood's fatigue reaction is when haloarenes react with alkyl halides along with sodium in presence of either, you are getting alkyl substituted benzene or methyl or ethyl substituted benzene you are getting. So when example chlorobenzene on reaction with two molecules of sodium along with an alkyl halide, that is CH3Cl, in presence of ether, you are getting toluene. That means on the benzene ring you have CH3 group. Then 2NaCl is a byproduct. 2NaCl. So what's fatigue reaction? In which haloarene reacts to sodium and alkyl halide in presence of either, you are getting alkyl substituted benzene. Here it is toluene. Okay, these are the reactions of haloarenes with the metals, and that is all about today's session. Thank you.